elementary class. This is section 3.3, starting with rotations. You're going to want to make sure that you locate your notes for section 3.1 and 3.2. That was reflections and translations, so make sure you locate those. You might even want to drag them out right now. I'm going to go ahead and just look through the first example on 3.1 and 3.2 just so we can kind of remember what they were about. The first one was reflecting. It was pretty basic. You guys caught on to it really easily. Reflecting this triangle ABC across this vector, we're going to want to take point A, point B, and point C individually and just draw them across this line. But the key is that you want to make sure that when you, I'm going to use my straight edge here, when you reflect point A across this line, it has to be across a line that's perpendicular to my vector here. So do you see how my straight edge is perpendicular to my vector? I'm going to draw a line, just like that. There's my perpendicular, my 90-degree angle. I'm going to do the same thing for B, and the same thing for C. And those are each 90-degree angles, okay? And then what I'm going to do is I'm going to measure, and I had you guys do this with a note card because it made it a lot easier to measure. Here's my little note card here. A is I mark on my note card that far away from the line, and I'm going to move it down, and it's going to be about there. That's where A prime will be. B, I'm going to mark on my note card. He is there, and I'm going to scroll down, and there's my point B prime. And C is really, really, really close to the line, and there's my new C prime. And then I just connect those. Oh, I should have done that with a straight edge. And there's going to be my new reflected image, okay? But the key there is you want to make sure that the line that you reflected across is perpendicular to your vector, okay? So that was the first example for section 3.1. 3.2 is translating things. Drawing a translation, they want us to take and slide this image across that vector. So what I'm going to do is this W here, I'm going to again use my note card, and this vector, I'm going to measure on my note card, is about that long. So I mark it on my note card here. And what I want to make sure and do is I want to slide Z, X, and Y up this direction because that's the direction my arrow is pointing, but I want to make sure I slide it the same distance as my vector. So I'm going to take this paper and I'm going to flip it around here, and I'm going to make sure that I slide, let's start with Y. I want to slide him up this direction, and my Y is going to be up here. Now, the key here is to make sure that this line right here is parallel to this line. So, for example, I'm not going to want to slide him up like that because that's not going to be slid in the same direction. So I want to make sure that he is parallel wherever I'm sliding him, and he's going to go from there to about there, and this is going to be Y prime, X, sliding him again, parallel to the vector, X prime, and this is Z prime. Okay. You guys should all have this filled out already on your notes. This is just review. Okay, so I'm just taking this guy and I've slid him up the distance, the vector, in the same direction. Okay. All right, so moving on to 3.3, rotations, okay? In each one of these sections, we've talked about before that there's a difference between similar and congruent. Congruent, you might want to add this to your notes. Congruent is when I take two objects, like let's say two triangles, and I am going to move him, I'm going to flip him, I'm going to do something to him so that they stay exactly the same shape and same size, okay? Similar, pretend those are the same shape and same size. Similar is where I take something and I make it either larger or smaller or something like that. So they are the same shape but different size. And that would be like a dilation. We've talked about that before. So congruent in each one of these sections, 3.1, 3.2, 3.3, we are keeping an object the same shape and same size. All right, so rotating things, counterclockwise versus clockwise. You guys should know what that is. Vocabulary words in here are center of rotation. So if I'm taking like point A and I'm rotating him, I have to know where I'm rotating him about. So point C is my center of rotation, and I'm taking him and I'm rotating him up this direction. He should end up being the same distance away from C when he was here as he is when he ends. So same distance from C from where he starts and same distance from where he ends. You can see that by the little tick marks here. Okay. Center of rotation, this one I'm moving 120 degrees, and that would be in the counterclockwise rotation. All right, angle of rotation, they tell us is 120 degrees. Now, sometimes they will not tell you clockwise or counterclockwise. If they do not tell you, you assume it's going to be counterclockwise. On a coordinate plane, if I'm looking at, like, let's say a side of an angle here, and let's say I have, this is my angle, okay, there's an angle going on here. This guy is measured up this direction, so it's like taking this side here and rotating him up here to form my second side, okay. Every angle, this is what's called standard position, if you've heard me talk about that before. Let's say I do another one, here's one side, and I rotate him around this direction, okay? That's where he ends. So if they don't say standard position, always says you rotate counterclockwise. You're going to start here, and you're going to rotate him counterclockwise in that direction, okay? All right, so draw a rotation. This one doesn't have actual coordinate points like we do down here for the second example. But we're going to use a protractor and a ruler to draw this one, all right? So what I'm going to do first is I am going to draw and connect A, B, and C all to that point K. My child is crying in the background. Ooh, that was really bad. My protractors are at the front of my room if you haven't found them already. You might want to go grab one. They should be on the front shelf. I don't know, like the second shelf down, maybe. See if you can find them. All right, so I've connected each one of the A, B, and C points to point K, and they want us to draw a 140-degree rotation. Now, they don't tell us clockwise or counterclockwise, but I said if they don't tell us, you always go counterclockwise because he rotates this direction. So I want to do a 140-degree counterclockwise rotation. So if this is one side of my angle here, I want to do another one that's 140 degrees, so A is going to end up somewhere over here. Okay, so I'm going to put my little crosshairs on K. So this center right here of my protractor is going to be on K, and the line is going to be connected this way to A, and I'm going to go on my protractor to 140 degrees, and this is upside down. 140 degrees is about right there. Okay, you see my 140, that's upside down. I need to flip my protractor over. So there's that, and I'm going to draw a line connecting them like this, just a really light shaded line. So A should actually be somewhere over here. Now, I don't know where to put A on this line. Is A here, or is A here, or is A here? So what I'm going to do is I'm going to use my little piece of paper or whatever you choose to use, and I'm going to mark A. He is that distance away from where K is, so I'm going to go over here on my line that I've just created and mark the same distance, and my A prime will be right here, A prime, okay? I'm going to do the same thing for B and C, so let me get rid of all this scratch work in here. B, this guy right here, he is along this line, this bottom line on K, so I'm going to do 140 degrees. Here is I put my center there on where K is, B is over here, and so I have that straight line on the bottom of my protractor. 140 degrees is up right here. And then I'm going to draw my line connecting to K. Something like this, okay? Measure where B is. And then this is where B will go. B prime, just like that, okay? If I went too fast there, go ahead and rewind this video if you didn't catch all that. C, I'm going to do C now, so center and on those crosshairs, 140 degrees is there. And I'm going to draw my line, and C is about this long, and C, transferring it over is about there. So this is C, C prime. Okay, now here's the moment of truth. We have to look at our image and see if it looks like we have taken our image and rotated him. So does this object look the same size and same shape as what that object is? I've just taken him and rotated him up. Yep, pretty close. Okay, so that's what actually physically rotating an object looks like. Down here we're going to use some cheating methods with some coordinate points, and that's going to make it a little easier for us. So that was the longest part. There are some ways to cheat, and we kind of went through this when we were doing reflections in section 3.1. If you are rotating something 90 degrees, so if we're taking this point P and we're rotating him 90 degrees about the origin, okay, origin is the center of rotation here. We're rotating him 90 degrees, so this is a right angle here, okay. When you're doing that, what will happen is this coordinate 5, 2 will become, they'll flip around. So instead of being 5, 2, it will be 2, 5, but the x coordinate will become negative. If you look at this little cheat sheet over here, the x and y will become negative y comma x. So they'll flip around, and then the first coordinate will become negative. Okay, the y coordinate over here will become negative over here, and it will be in the x spot. Okay, 180 degree rotation is kind of like reflecting something about the origin. So we've already seen this before. 180 degree rotation is the same thing as reflecting something about the origin. And in that case, xy becomes negative x, negative y. They stay in the same spot, but they become negative now. So 5, 2 becomes negative 5, negative 2. Okay, they flip, they stay in the same spot, but they become negative. So you're going to want to remember that, circle that guy. And 270 degree counterclockwise rotation, because we're always going counterclockwise. So really, 270 degrees. This is a 90 degree angle. 270 degrees is kind of like negative 90 degrees, if that makes any sense to you. Negative 90 degrees would be like going the opposite direction 90 degrees, okay? If you want to think of this one up here as a negative angle, this is going to kind of be funky. 90 degrees in the positive direction would actually be negative 270 degrees, okay? So if you kind of want to toy around it by thinking about angles that way, we do a lot of that in trig, and you might have already done that in chapter 8 with Mr. Getzfred. So negative angles and positive angles. 270 degree rotation, you're taking the x and y coordinate and you're flipping them around, but this time the second coordinate becomes negative. So the original x coordinate becomes negative, and it switches to the y coordinate. So that's kind of your little cheat sheet there. That's what will happen when you're rotating coordinates, okay? So we're going to use that cheat sheet, and we're going to go down here, and we are going to figure out what each one of these will become. So 1, 1, 4, 5, and 5, 1. I'm just going to start by writing those out here like this, because this is just better organized. Okay, and I'm going to show what they will become. From before, you might remember that we call them the prime. So this is P prime, Q prime, and R prime. And they're going to have new coordinates, okay? All right, now let's figure out how we're rotating it. And graph the triangle PQR and its image after a rotation 90 degrees about the origin. They don't say what direction, so we assume it's counterclockwise. 90 degree rotation means that I'm taking the x and y coordinate and I'm flipping them around, and then the first coordinate becomes negative, okay? So I'm taking these two guys and I'm flipping them around. Well, 1, 1, if I flip it around, it will stay 1, 1, and the first coordinate is going to become negative. If you're wondering if that coordinate is already negative, then it just becomes positive. You just change the sign of it. So 4, 5 will become 5, 4, but that first coordinate will become negative. If it's already negative, you make it positive. 5, 1 will become 1, 5, and the first coordinate will be negative. All right, let's graph both of these and let's see what they look like and see if it actually does look like a 90 degree rotation. So the first one is 1, 1, 4, 5, If you need to pause to graph, you can, because I'm going to graph these really fast. So this is P, Q, nope, PQR. Okay, that's PQR. Then we have negative 1, 1. That's P prime. Negative 5, 4. Q prime, and R prime is negative 1, 5. Sorry, up here. R prime. So he is taken, and I've just taken him, and I've rotated him up this direction, 90 degrees. Okay, so you can kind of see how that will look. Another way of doing it is if you take and just look at this image right here, just focus on him. If you rotate your paper up 90 degrees, that's what he should look like. Okay, I've rotated my paper 90 degrees. So this image right here is what he should look like. If I go back, so he's kind of in like the second quadrant. If I go back, he's in the second quadrant there, and that's exactly what it looks like. Okay, all right, let's do this other one really fast, and then we'll be done. All right, so A, B, C, negative 3, 6, negative 6, 9, and negative 8, 5. Okay. Oh, shoot. Now we have a point that we're graphing about. Negative 5, 3. Okay. So we're not reflecting him about the origin. We are reflecting him about the point, or we're rotating him about the point negative 5, 3. So I'm going to go ahead and graph these and see what we've got going on here. So negative 8, 5, I'm off the chart here. Negative 8, 5 is this point. Negative 6, 9. Boy, I really just did good here. So this is my triangle that I've got going on here. And I want to graph him about the point negative 5, positive 3. So I'm going to rotate him about the point negative 5, positive 3. Okay? All right, so this one is kind of nice. And really the only thing that you can do here is when you have a point that you're graphing him about, you can look and see how the book does it. But the easiest way to do it, I think, is to just think about what a 180-degree rotation would be. So if I look at this point right here, he is 2 to the right and 3 up. So what I'm going to do is I'm going to do exactly the opposite of that to go 180 degrees. I'm going to go 2 to the left and 3 down to get my new point. Okay. This point right here is 1 to the left and 1, 2, 3, 4, 5, 6 units up. So I'm going to go 1 to the right and 6 units down to get my new point. Okay. This guy right here is 1, 2, 3 units to the left and 2 units up. So I'm going to go 3 to the right and 2 units down. That's what a 180-degree rotation would be. You're doing exactly the opposite, because 180 degrees is taking x and y, and it's making it negative x, negative y. Now, the reason why I can't just do, make this become positive 8 to negative 5 is because I'm not rotating it about the origin. I have to take into consideration the point negative 5, 3. So that's the easiest way for me to think about it, is to actually graph it and then move those points accordingly. So this point right here would be, oh geez, which one is A? This one is A, negative 6, 9, this is B, and this is C. So A would be here, A prime, and that's at negative 2, 1. B prime is, B prime is here. Negative 4, negative 3. You people with bad handwriting, you're going to have to do something. And this one is at negative 7, 0, it looks like. There we go. Okay. So graphing was probably the best option. You can look and see how the book does it. They might do it some way different, but this is how I think it's the easiest. So there you go.